share.
Privacy. Select screen recording. I don't. Okay, here it is. Screen recording. And maybe add. Allow the apps below to record the contents of your screen. Click the tick box next to an app to allow it to record your screen. I'm not doing screen recording actually. I just want to share my screen.
Yeah, so if you're on a Mac, you have to, in system preferences, you do actually have to grant that permission to share your screen. And then I believe you have to restart your browser when you after you grant that.
Okay.
Yeah.
So I think hopefully everybody is here. It's 7 at my end, 7 p.m. So seems like the time. So, okay, let's see the first paper. Actually, I just want to make unofficially that everybody is here. Chekrit is not here. Is there anyone from SQA Planner paper? And they are not included in the recording. Okay, let's start the session. Welcome to the Humans and Machines session. And I'm Sandeep Kuttal, and I will be chairing this session. We have 5 interesting talks, 3 journal first and 2 technical tracks. And in total, since we have 5 presentations, each presentation is 5 minutes long. And like the presentations will be one followed by other. And then in the end, we will have 30 minutes for discussion. So the very first paper is SQA Planner, Generating Data-Informed Software Quality Improvement Plans. It's a journal first presentation, and Chekrit is going to do the presentation, but do we see him?
I don't believe he's in the room yet.
So one way was to show the recording.
Mm-hmm.
So do you have access to this program, like the conference program? Actually, there are videos. I'm just gonna paste it here, and since maybe your computer works.
Hi, Sandeep. Sorry, can I just jump in? So I'm from the same lab. I'm not on that paper, but if you wanted to shuffle the order of the presentations, I can try and get in touch with them.
Okay. Anod, are you ready? Since maybe you will get a little bit more rest. Can you present? Can you go first?
Sorry, so I'm not going to be authors. I'm not going to be author of this session.
Yeah. What I'm asking is Anod, like the second paper. So the second paper is Interacto, a modern user interface processing model. Will you like to present, Anod?
Yes, I can start.
Okay, thank you.
Okay. Let's go sharing the screen. Yes. Does it work?
Yes. Thank you.
Okay, hello everybody. I'm Arnaud Blouin from University of Rennes, and I will shortly present Interacto, a modern user interaction processing model. So we interact with computer systems to control them, to interact with their data, to handle their data, and all the user interactions of a software system form a kind of dialect between the users and the system. For example, the swipe, the drag and drop, the drag lock, etc. And currently, for processing user interactions, software developers use the event processing model. So I have this small example here that consists of using a drag lock. So a drag lock is a kind of drag and drop. First you double click, you move the mouse, and then you double click. We use here the double click to move an object. So at the first double click, we change the cursor, then we register to the move event. Then we can move the mouse so that it moves the command, it moves the object under control. And at the second double click, we set back the cursor and we remove the mouse move event. And that's only if the primary button of the mouse is used. So in this example, we can see that there is somehow some spaghetti code. In the same code, we have the definition of the user interaction, we have the transformation of the user interaction into a command, some optimization, some feedback, and some constraints. And moreover, this model lacks some advanced features. For example, there is no tangible undo-redo mechanism that developer can cancel. So in fact, instead of processing low-level event, developers should focus on selecting a specific user interaction. Developers are not HCI designer. They should not develop user interaction. They should use them. So select a user interaction, parameterize it, and then specify how the execution of the user interaction can create an undoable command. For example, using the same example, developers should write something like that. I want to use a drag lock on this object to produce a command. When the drag lock starts, I want to do something. When it stops, I want to do something else. And during the execution of the drag lock, I want to, for example, update the translation vector of the command. And that's only if the primary button of the mouse is used. So, I mean something more declarative. And typically, Interacto works like this. A developer do not handle low-level user interface events anymore. They focus on selecting a user interaction, specifying the command they want to produce, and specifying how the execution of a user interaction can produce a command. So this is what we call an Interacto binding. And Interacto binding are contained into context that also provide a local undo-redo history that is customizable. So using the previous example, we have something like that. From a context, we select the interaction we want on the specific interactive object. We specify the command to produce. When the interaction starts, I want to do something. When it ends, I want to do something else. And during the execution of the interaction, I want to update the command. And that's only if the primary button of the mouse is used. So this is a Fluent API. We call an Interacto binder. In fact, the binder is used to configure the Interacto binding that will be used. So user interaction is the main concept in Interacto. It is separated in two components, interaction data and behavior. And data are used for interaction substitution. For example, here we have the family of the drag and drop. So in this family, we have the drag lock, the drag and drop, the drag and pick. But developers never handle directly interaction. They handle the data. This enables, for example, to substitute a drag lock with a drag and drop without any change. The other concept is command. So a command is an object that defines how to operate on the data. And a command also specifies the undo-redo operation if the command is undoable. The Fluent API of Interacto binder also have multiple routines to configure the Interacto binding, such as catching error, throttling events, etc. Okay, that's it. Do not forget to see the full video on YouTube. Thank you, everybody. I think it's 5 minutes.
Thank you so much for taking.
And here you have a tiny example of undo redo. Yep, sorry.
Yeah, I was just gonna say thank you for taking the first, and presenting like it wasn't your. So the next presentation I see Shakrit. So SQA Planner, generating informed software quality improvement plans. It's a journal first paper.
Hello, yes. Is everyone hear me?
Yes, we can hear you. Can you try sharing your screen?
Yes, I'm trying at the moment. 1 second. Do you see my share screen? Yes, hello.
Yes, we can see it. Go ahead, please.
Yep. Okay. All right. Thank you. Yep. Thank you, everyone. So, hi there. My name is Kla. I'm Shakrit Tantitam Tawan from Monash University. I'm here to present the paper titled SQA Planner, Generating Data-Informed Software Quality Improvement Plans, which is accepted at IEEE Transactions on Software Engineering. This work is in collaboration with Delini Rajpaksha, Jirayut Jain Pakdi, Christoph Bergmeier, John Grundy, and Ray Bantai. So as everyone knows that software defects are widespread but hard to predict and prevent. Defect prediction models are proposed to predict if a file will be defective in the future or not. And traditionally, we often use a historical data from previous releases as a training data to build a defect model. And then we apply the defect models to each file in the current release or a testing data to generate the predictions. And such predictions will help developers prioritize their limited resources on the most risky files instead of testing all of the files in one release. And the most important factors also help managers develop better quality improvement plans as well. And such defect prediction models have been used in many software companies like Google and Microsoft. So let's consider this tool, Microsoft Code Defect AI, as an example. This defect prediction tool aims to predict if this Java file is likely to be defective in the future or not. So the tool predicts this file as yes, with a confidence score of 70%. This tool also uses LAMP to generate an explanation. Like in this case, it says that lines of code contribute the most to the prediction. So it implies that developers should do something about the lines of code to mitigate the risk of having defects. While this tool is quite expandable, but they are still not actionable yet. Importantly, practitioners still don't know what should they do to decrease the risk of having defects and what are the risk thresholds for each metric that it should be. Like in this case, when the tool said lines of code contribute the most to the prediction, but the key question that remains unanswered is that how small it should be to be considered as non-risky. So we propose SQA Planner, which is a local rule-based model agnostic technique from the explainable AI discipline to generate explanations and actionable guidance. So conceptually, our approach consists of 3 steps. First, we use crossover and mutation to randomly generate the synthetic instances around the neighborhood of an instance to be explained. And then we construct an association rule model using magnum opus in order to generate an association rule explanation that achieves the highest accuracy. So let's assume that we have a defect model with predictions from buggy to clean. Our SQA planner will take a model and the instance to be explained as an input in order to generate different types of association rules. Like in this example, this rule means that this file is predicted as defective since lines of code is greater than 100 and the degrees of ownership is less than 80%. So this kind of knowledge will help developers understand what are the most important aspects that are associated with the software defects and help developers understand the risk threshold. So when LOC is greater than 100, it implies that it will be predicted as defect. We could say that if LOC is less than 100, the model may reverse the prediction from defect to clean. To evaluate our approach, we investigate how accurate are our rule-based explanations using association rule measures and its consistency when they are regenerated. So we found that our approach outperforms the state-of-the-art approaches, model agnostic technique like LOR and Anchor for both aspects. So we conclude that our SQA planner can generate explanations that achieve the highest coverage, confidence, lift consistency when compared to the LOR and Anchor. However, association rules are very complex and they are very hard to comprehend. So we try to translate the rule explanation into a nicer visualization to see like if they are more actionable or not. Like in this case, instead of explaining why a file is predicted as defective, we're going to provide some actionable guidance to developers. What should they do to decrease the risk of having defects? Like for example, this one, the first one, decreasing the lines to less than 29 lines from the actual 34 lines. So we again ran a survey with practitioners and we found that 80% of the respondents agree that this visualization is better for providing actionable guidance than the Microsoft Code Defect AI. So in conclusion, we just want to, the takeaway message of this work is that actionability is very much needed in software engineering, and SQA Planner is one of the important advancements towards the actionable software analytics. So if you are interested in the areas of expandable AI for software engineering, please feel free to check our online book, xai4se.github.io. And if you are interested in collaborating with us, please feel free to contact me. Thank you for your attention.
Thank you. The next paper is a comparison of natural language understanding platforms for chatbots in software engineering. And Khalid and Ahmed, are you both going to do the presentation? Or just Khalid?
I will do the presentation.
Okay.
Yeah, let me share my screen. Yeah, can you see my screen?
Yes.
Can you see my screen?
Yes, we can see it.
Hello?
We can see it.
Okay, cool. So I will start. So, okay. Hello, everyone. Again, my name is Ahmed Abdel Latif, a postdoc at Concordia University. And today I will be presenting our work, a comparison of natural language understanding platforms for chatbots in software engineering, which was published in the Transaction Software Engineering Journal last summer. This work was done with my colleagues, Khalid Badran and Diego Costa under supervision of Dr. Imad Shihab. Chatbots are one type of software bots that automate tedious tasks and able to communicate with users through natural language.
Ahmed, sorry to interrupt, but you're not sharing your screen. You're sharing the presentation, but not the presentation screen.
Okay, let me stop here. What about now? Or is it still the same?
Yes, now we can see the full screen.
Yeah, we can see the whole
Sorry?
screen.
It's okay.
Yeah, we can see the whole screen.
Okay, cool. Okay. Recently, many chatbots have been developed to help software practitioners in performing different tasks, such as answering questions related to the software repositories, managing the development tasks, and help developers to maintain their microservices through natural language. And at the heart of every chatbot, there is a natural language understanding component, or called NLU. This component is responsible for interpreting the user message by extracting structured information from unstructured user's input. More specifically, when a user inputs a message, this component extracts the intent behind the question and the entities which are the important piece of information with a confidence score that shows how trustworthy the classification is. Developing an NLU from scratch is very difficult because it requires AI and NLP expertise. So, chatbot developers typically use an on-off-the-shelf NLU such as those developed by Google and Microsoft in their chatbot implementation. However, selecting the most suitable NLU for the domain of the chatbot is vital because it significantly impacts the user satisfaction. Choosing the best NLU for software engineering chatbots remains an open challenge. Therefore, in this work, we set out to answer this question: what is the best NLU for software engineering chatbots? To answer this question, initially, we need to choose the candidate NLUs. We selected to examine 4 widely used NLUs, namely IBM Watson, Dialogflow, Rasa, and Microsoft LUIS. Next, we select tasks to evaluate the NLU's performance on. In particular, we selected 2 queries that are related to 2 software engineering tasks. The first task is exploring the project repository data task. This corpus is a set of 400 queries with 10 different intents and 4 entity types such as file name and Jira ticket entity. The other task is related to technical questions that developers frequently ask and answer from QA websites, such as Stack Overflow. The Stack Overflow corpus contains 215 queries with 5 intents and 5 entity types, such as programming languages. For the NLU evaluation, we trained the NLU on both repository and Stack Overflow corpus. And our last step in our methodology is to analyze the results for each NLU to find the best NLU platform to use for software engineering chatbot. More specifically, we followed an approach from prior work to rank the NLU's performance in different tasks: entity classification, confidence scores, and entity extraction in both repository and Stack Overflow tasks to compute or obtain an average overall rank. So, for example, IBM Watson in the repository task achieved the best performance in the entity classification, so we ranked it here as number 1. However, it came third when extracting entities in the repository task. Then we computed the average rank in all aspects for both tasks, and we computed the average overall rank. So the NLU with the lowest average rank is the best NLU. And we find that IBM Watson achieves the best results, followed by Rasa, Dialogflow, and LUIS. To conclude the presentation, first we discussed that selecting an NLU is vital to the chatbot. Then we explained our methodology to find the best NLU for the software engineering domain. Next, we present the corpus used in the study. And finally, we present the overall rank for the NLUs. Thanks for your listening.
Thank you. The next paper is on the importance of building high-quality training data sets for neural code search. And is anyone here to present it, because I don't see the names of the authors? Is here anyone present to present this paper or no? Z, can you try the video? It should be in the program.
Okay. Or why don't we let
or we can just do Madeline. Yeah, so you can try seeing if you can do the video. Madeline,
sure.
For doing presentation?
Yes, I can do that.
Yes, thank you. So the next presentation is by Madeline, Hashing It Out, a survey of programmers, cannabis usage, perception, and motivation. Yes, please go ahead.
Let me just get the the presentation set up. Sorry, 1 second.
Done.
That's the one we want. And let's share that. Okay. Can people see my screen?
Yes, we can see.
Excellent. So let me get started. Okay, cool. Hello, my name is Madeline Endries, and I'm a PhD student at the University of Michigan. Today, I'll be talking about our paper, Hashing It Out, a survey of programmers' cannabis usage, perception, and motivations. Now to start, I'm going to talk a little bit about the background of cannabis use. Cannabis is one of the world's most common illicit substances, and it's used for many reasons, but the global legality of cannabis is changing rapidly. For example, it's currently illegal in many countries, including the United States and China. Okay, so why are we talking about cannabis here at ICSE? Well, perhaps surprisingly, there is a large amount of anecdotal evidence connecting software engineering and cannabis. There are hundreds of forums and blog posts by programmers on sites such as Reddit and Quora talking about cannabis. Many posters share their own experiences using cannabis while working or claim that cannabis enhances programming. Altogether, these anecdotes point to a cannabis-related subculture in software. However, many programming jobs, especially those that rely on federal funding, have and enforce anti-drug policies, such as the one on the screen from Cisco. Additionally, we find in our research that almost 30% of programmers have taken a drug test for a software-related job. This conflict between cannabis use and drug testing software jobs can actually lead to hiring shortages for those companies who drug test. One such shortage occurred when the FBI said that they were having trouble finding hackers to hire because all of them were smoking pot and thus could not pass the required drug test. Despite this apparent conflict, surprisingly little empirical research has been conducted on cannabis use in software development. In fact, it remains unclear if, when, or why developers use cannabis while programming. As a result of this knowledge gap, tech companies cannot effectively evaluate existing anti-cannabis policies. In this talk, we start to close this gap by presenting the results from the first large-scale empirical study of cannabis use in software. Now, to do this, we conducted a survey which we sent to developers from popular GitHub projects and to current and recent graduates at the University of Michigan. We received 803 valid responses. Over half of the respondents had a full-time programming-related job, and the most common job title was software engineer. A more detailed breakdown and contextualization of our population can be found in our paper. So now that we've covered our methodology, it's time to go into the exciting bit. What did we find? Okay, so to start, do programmers in our sample use cannabis while programming? The answer is yes. Over 1/3 of our sample have tried cannabis while programming at least once. Of those, over half do so on a regular or semi-regular basis, and 11% use cannabis while programming almost every day. This usage is likely to be detected by a drug test. Cannabis while programming is most common among men, transgender participants, and developers recruited from GitHub. This last result may indicate that cannabis use is particularly prevalent in open source communities. Okay, so when do programmers choose to use cannabis? We find that programmers are most likely to use cannabis during personal programming projects. However, 1/3 do choose to use them during work-related tasks, a likelihood that increases when developers work remotely. Okay, now to dive into this usage a little bit more detail, here's a list of common software engineering tasks that are ordered from those that developers are most likely to do while using cannabis to the least. The most common tasks are generally those that require a lot of creativity, such as brainstorming. Cannabis use is much less likely during detailed-oriented tasks or tasks with an imminent deadline. This indicates that developers tend to self-regulate their cannabis usage while programming, a finding which may call into question blanket anti-cannabis bans. Now that we know when programmers use cannabis, let's explore the why. Overall, we find that cannabis use is mostly for enjoyment or perceived programming enhancement. For instance, over half of programmers use cannabis to make programming tasks more enjoyable or to think of more creative programming solutions. However, not all opinions are positive. For instance, this participant managed several programmers who fully believed that cannabis was helping them program, but from the outside, they had many different code quality issues. Now, negative opinions such as this were relatively rare. 27% of managers in our survey suspected an employee used cannabis, but less than 3% reported decreased productivity. However, these conflicting opinions motivate future observational research on the actual effects of cannabis on programming. Okay, so in conclusion, we ran the first empirical evaluation of cannabis use in software engineering with a survey of 803 programmers. We found that 18% of our sample use cannabis while programming at least once a month, and many do so while completing work-related tasks. This use is generally motivated by enjoyment or perceived programming enhancement, and managers rarely report witnessing negative effects. Even so, 29% of our sample have taken a drug test for a programming-related job. Thus, our results show a conflict in the preferred practice of some developers and company policies. So thus, our results encourage a re-evaluation of anti-cannabis policies and software-related jobs. Finally, the intersection of cannabis use and technology remains underexplored even outside of programming contexts. As cannabis becomes more acceptable, it may interact more with socio-technical issues such as accessibility or end-user security or algorithmic bias. We hope our work spurs more research at the intersection of technology and mind-altering substances in general. Our materials are available on the project website, and then also I'm looking for research internships in 2023. So if you're interested in chatting or collaborating, definitely reach out. Yep.
Thank you. Okay. Can we find the fourth paper or no?
I found their.
I think we can. I'm thinking we can skip because they won't be even available for discussion. So what's the point? Like, looking at nobody can even discuss about it, and we have 30 minutes for discussions. Then we can have a healthy discussion between 4 papers. So I will go with the sequence. First is for Ahmed. The question in the chat Peter has asked. Thanks for your presentation. I take it your results are from the models that you trained using GitHub or Stack Overflow data, right? And did you do, or does it make sense to do a comparison with results from the base model, Watson, Rasa, before they were trained?
Yeah. So first of all, thanks for your question. These NLUs, in fact, are not typically trained models, but rather platforms that can be trained given some data. So we need to train them before using them. Therefore, we would not be able to use them as a baseline in our setup. I hope I answered your question.
So is there any way, there's no kind of transfer learning that you can do from this? There's no sort of general, I suppose intent classification is tricky, but is there any intent classification, just general data sets that could have been used and use that as a comparison? I think oh, you okay? I think you might have dropped out.
Khalid,
Ahmad,
maybe you can answer if Khalid, you can.
Yeah. I was
sorry.
just.
Yeah, go on.
Oh, sorry. On you go.
Actually, I did not hear the questions correctly because the internet connection was unstable on my side. So, Khalid, if you hear the question, feel free to jump in, please.
So yeah, I was kind of asking about whether you can compare it with non software engineering data sets as well to see whether it's a kind of software engineering specific result or whether it's a result of the kind of overall architecture of the models themselves.
So okay, software engineering. Okay, so there are some general models that came with the NLUs, but they are not related to the software engineering. Are related to the, for example, to the music domain, to the development domain, and there are previous research there. For if we want to compare the results of our study to the prior work, we found that there is some discrepancy. For example, Microsoft Lewis achieved the best in the weather domain, if I recall correctly, but in the software engineering domain, in the intensity classification, it did not perform well. Did that answer your question? I hope.
Yeah, that's really interesting that it is quite specific to software engineering then. I wonder if, there's something to do with the kind of secret sauce of how Watson is trained that it becomes the best at software engineering when it might not be the best for other domains. I mean, it's a bit frustrating that it's closed source, but yeah, that's a cool result. Cheers.
Yeah, and Peter, just want to invite you to read our article, our study, the intensity classification, because there you will find that the NLUs misclassifies some normal words with the class names. For example, the word "a." For example, I read an article or I read a website, right? It considered "a." here as a class name because it has been trained on class or file names A to Java, right? So it will classify it here without specifying the context. Yeah.
Cool. Cheers. I'll look more into that, but thank you very much for the presentation. Cheers.
Thank you, Peter, for your question.
So, okay, the next question is for, I think it's for Madeleine. How do you identify the 803 target participants and ensure that they use Canvas? Yeah.
Yeah, I can definitely talk about that. I think part of it is when it's such a short presentation, it's hard to get a lot of the methodology in. But basically, we weren't assuring that we had people that could use Cannabis. What we were actually doing was aiming this at all developers and then seeing what percentage of them did use Cannabis. So we emailed, I want to say, about 5,000 people from GitHub and slightly less than that, but similar from previous recent University of Michigan graduates. And the respondents that we got back that were valid, so passed all of like the data quality checks, completed the whole survey, all of that, were 803. And then of those, it was about a third had ever used Cannabis for programming related tasks. So there were some people in there who had never used Cannabis, and we were very explicit with our recruitment. Obviously, there may still be selection bias for people who would take it or not, but that was kind of our methodology there.
Yeah, thank you. So other question is from Rashina Hoda, and she asked, she said, fascinating work. We have talked about this before, but for the benefit of the audience here, what were the barriers, if any, you encountered in addressing such a controversial topic, and how did you overcome them? And I think I also had the same question, like, how did you go to your IRB?
So yeah, I can give you so many stories about the IRB. Oh my gosh. So with this particular one, the IRB actually wasn't too bad for this one because we were keeping everything anonymous and confidential. So we were using other sort of data quality checks, like questions where we're expecting results to correlate, like you shouldn't have been using Cannabis longer than you were alive, those sorts of things to make sure we had data quality. And that way we didn't have to collect anything like IPs or names. So this one, because we organized it that way, and I worked with someone who's done this sort of research before to know how to do that, we were able to get, I think this one was exempt, but I have a lot of follow-on work that's either not exempt or very close to not. So for example, I'm doing right now an interview, more qualitative-based study where we're exploring this a bit, and by its nature, that can't be fully anonymous because you're on a video call with someone talking about potentially illegal things that could get them fired. And so being really careful about your data security, we had to outline like everything that we were going to do for the data security for that. And then I have a future study that I'm planning, which involves actually having developers program WillHi. And that one we've been talking with like the IRB's IRB for a while. So it's really important when you're doing this sort of thing to do things as ethically as you possibly can. But I also think that this research is important. And so it's worth the trouble.
Any other questions? So if not, I have few questions, and maybe I will start with Arnaud. Interactive evaluation, like, can you a little bit put some light on how the evaluation for interactive was done? And the other question is, like, what do you think, like, compared to conducting user studies, or like, you know, in HCI, we conduct a lot of user studies, like how it is different, or like what factors or what are the advantages of having Interacto over conducting user studies?
Yes, so regarding evaluation, in fact, we have two main evaluation. It's how to start. The first one, in fact, we conducted a very long study since 2030 by developing an open source software system using Interacto. It was a drawing application, and in fact, we switched with Interacto, and yes, we experienced various things using this long-term use case. And more recently, we conducted an empirical study with 44 master students in computer science, in fact, with on 3 representative exercise. And the research question was, does Interacto, I can't remind me exactly the research question, but it was, what was the benefits in terms of tile correctness, and does it help something more qualitative than the quantitative? And the results was, Interacto is at this time of the experiment, it was benefits in particular for reusing predefined user interaction, for providing a dedicated undo-redo mechanism, but there may exist a learning gap to understand, to master the Fluent API, because even more master student may not master, for example, arrow function, which is something to be used in Interacto. And sorry, your second question was about. Oh, your mic is off.
Yeah. So I was asking, can you see like some implication of Interacto for over like usability studies, or like, you know, in
Yes.
because it's about interaction, isn't it? So, which is human-computer interaction. So.
You mean can we use Interacto for usability evaluation, or
Yeah,
we,
like what will be the advantages, or how you can see it being used there?
We started to integrate. In fact, one benefit of Interacto is that it's you handle interaction and you are at a correct abstraction level, and we integrated in Interacto some facilities to compute some usability metrics. For example, the Fitts law, which is something very classical in HEI. To compute, it computes, I don't know if you know Fitts law, but it's something used to measure the performance somehow of user interaction, of a layout. And we integrated that. It's done automatically as a usage logging facilities. So we started with that for the moment.
So Fitts law is about size of the object and distance from where it is. So basically, you calculated that while integrating with Interacto. Okay.
Yes.
Okay. So where the object and then the distance. Okay, that makes sense. Okay. So the other question is for comparison of natural languages for Ahmed and Khaled. Yeah, so like, you know, you compared like, you know, the intense, like basically for software engineering, you compare these different NLU, like basically like off-the-shelf components which can allow you to create a chatbot. Can you based on the like ranking, because some were good at intent classification, some were good at entity classification, can you think of implications like based on like intent or based on entity, like where one model will be better than the other model? Does make sense? Like what I'm trying to answer?
No, absolutely. Yeah. I mean, Ahmed might have the internet, not sure. But yeah, absolutely. So this is why we kind of go in depth into each aspect in the paper more. So we go in for the entity classification and we show which one forms best. We do the same with the entity, and we do the same with the confidence. So as I said, you may want to use the NLU in different ways. So we know some corpuses do not have entities at all. So they just have intents. And in that case, well, you may just as well pick the NLU that has the best in intent classification only. You don't need to consider the entity extraction case. We also dive a bit more deep into entity extraction, because it's not only the raw performance. You also want to consider other aspects such as how good is the false positive rate. We know that IBM Watson, although its overall performance is really good, in entity classification it can be bad at providing a lot of false positives. So we do highlight that. We do highlight, for example, especially with the file name entity, if you want to use that, you may want to be careful with IBM Watson because it can go wild. And the other ones are a bit more conservative, and that's better for file names which are hard to kind of capture in entities. So absolutely, there's different use cases for when you look at the different aspects. This is very important for the evaluation.
Okay. Actually, I was asking a little bit different that what application or what implications can you think of when intent is more important and when entity is more important of software engineering? So for example, like if it is programming related, maybe like, where variable names are, which can change, maybe then like, entity is important, but maybe when it is just very simple kind of explanation kind of questions, like I was just trying to think from that perspective, like which model, like, how you decide which model to use for certain software engineering applications.
Okay. Well, yeah, that's the thing. So I guess if the context within software engineering has a lot of entities. So Stack Overflow, for example, the post title is kind of loaded actually with information. So usually users will mention which programming language they're using, which platform they're using, and whatnot. And those entities are important to capture if you are building a chatbot that can answer Stack Overflow questions or technical questions by users. So in that case, you absolutely cannot ignore the entities. You may even want to put further more emphasis on them, especially if there's multiple entities in the text. In other contexts, if your platform is just maybe managing some microservices, retrieving some simple answers that do not really require a lot of entities, then intents, or I can imagine some cases such as the MSR bot. That bot actually serves a lot of intents. So it has 40 intents or more. And in that case, you may want to focus on the intents because that's where the performance will actually show. Yeah.
So I want just to compliment on Khalid's answer. So basically, our results guide the chatbot practitioners. For example, if I want to develop a chatbot, and okay, I have the treasure to see which NLU to use. So in this case, we recommend if you don't know which NLU to use, to start with IBM Watson based on the results we have for the software engineering chatbots. However, if you want to, for example, if you want to, let's say, intents for repository, in this case, IBM Watson. But if you want, let's say, about entities for Stack Overflow, programming languages, about APIs, about documentation. So in this case, maybe you want to use Lewis, right? So, yeah, so, this is one thing. And also there is another dimension that we did not discuss it in the paper, but there is a good amount of research there in the literature. We need to consider, for example, the security, easy of training or evaluation, right? And the user interface. So there are some studies that do some evaluation or comparison for the NLUs in those aspects. The usability, security, readability, for example, such things.
Okay, thank you. So I will say the Peter's question for okay, he asked question and you answered, maybe, Madeleine.
Yeah, we had.
Oh yeah, go ahead.
Or is it the other way?
Okay. I just was enjoying the kind of conversation about that, and I of course your kind of experiment about doing it in a controlled setting, I think is probably the best way to go about that. I was also just thinking, stuff like the fact that employees have a less bad, kind of view of it, I think in general than managers as well is interesting. And I would be interested with the controlled experiment. Do you think you'll do any sort of, obviously I'm guessing you'll have like a control, but would you also have like an alcohol or caffeine treatment? I mean, again, that'd be more ethics stuff to get past. Maybe not caffeine, but alcohol would be tricky.
I mean, less bad because it's not in the US. Cannabis is Schedule 1, which means it's like our tier 1 of like bad. So it's honestly really obnoxious to do really any research with it. So it's decriminalized, or it's legal in Michigan, but for the whole US, it's not legal. But yeah, the current plans for doing an observational study would be having developers who have used cannabis. It wouldn't be exactly ethical to ask people to use cannabis for the first time for a study. I would feel a bit bad about that. But people that have used cannabis to come in and one time do it sober and one not. And it wouldn't be, we can't hand them product. We mostly just have to observe them doing product, because if you hand something product, it becomes a clinical drug trial. I know like all this like random stuff about IRB things for this at this point, but yeah, you observe different things. You have them come in and randomized order. So half of them will do the high one first and half of them will do the sober one first. And in that, I'm going to have a few different tasks. Some of them are going to be pretty quick, like short bug debugging sort of tasks, or like you fill in a variable or quick things. But then we'll also have like one or two longer, more like leak code style, like generative things. And I have some different hypotheses about more generative code versus debugging sort of things. So that's the current plan. But yeah, using something like alcohol or like, God forbid, like microdose or something would be really interesting. But that might be steps beyond this one at this point.
I can imagine like hearing, again, not like caffeine's usually strong enough for me, but like, yeah, from hearing a lot of cool stuff about, I don't know, yeah, as you say, stuff like microdosing, it'd be interesting to, just from a total kind of layman's point of view, kind of seeing how that would turn out. But yeah, sounds cool. Thanks very much.
Thanks.
I am mute. I was just asking, are there any other questions from anyone to other participants? Okay, so Madeline, I have another question. How did you guys created the survey, and how did you check the validity of that survey, whether the survey was like, because in HCI, we are very particular about how the survey is created and checked. So can you a little bit talk about it?
Yeah, so the survey was run just over Qualtrics, and when possible, we tried to use validated measures. So one of my co-authors, Kevin, his research is cannabis. So he's in the School of Medicine and does cannabis use for chronic pain and all of that different stuff. And so from him, I got a few different validated measures, basically, of self-reported cannabis use or cannabis history or all of those sort of things. So that built up the backbone of trying to get cannabis usage from them. And those also have some built-in tests to be like, is this a completely random answer, or those sorts of things. One of them even has a question like, when did you last have cannabis? And if it's today, or you get to another thing that says, are you currently high, and ask you like how high you are while taking the study. And then I also pulled like lists of software tasks from some established sort of lists of different types of software tasks. I forget which one I used. It's definitely cited in the paper. And we adapted some basic demographic surveys from some of the medical research as well. So whenever possible, we tried to use validated surveys. Obviously, with the cannabis plus programming stuff in particular, we're the first ones to look at that. So for polling some of the reasons why someone might use cannabis while programming, I did that by looking at a lot of this anecdotal data online. I looked for sort of themes that I'd seen, been like, oh, creativity, enhancement, brainstorming, and those were some of the options, but then we also gave a fill in the blank option as well. And also from the survey, I have a decent amount of, I guess, qualitative data that I honestly didn't really do much analysis for this paper, just because there was already a decent amount there. And so that's something that I'm currently looking at to dive in a little bit more.
And did you like also like had pilot studies and stuff? How did you got like, the iterations of survey? Can you talk a little bit about that?
So it was mostly like internally with either my co-authors or research collaborators. Some of the things that we were really concerned about is, well, like wording or how bias leaning different things sounded, all of that, especially for the questions that we were creating ourselves. The validated ones we just didn't want to touch as much as possible. But the reading, yeah, it definitely went through probably a month and a half of like iteration, going through different people to try and make it the best we could. But also it was challenging because we couldn't really go over 15 minutes, right? And there were so many things we wanted to ask, but you can't put that much in 15 minutes. And so picking what we wanted to do to make sure we could get enough questions to make sure we had high quality data for those things. Yeah, but no, yeah, survey creation is tough, and I think in the future I would love to like work more directly with people that do, I guess, like survey sort of data or as their research, or survey sort of methodology as their research. I think it's a really cool area.
Okay. Thank you so much, everyone. Does anyone have any questions, or should we wrap up the session? Because I know, like, there is like 3 o'clock in France and they're pretty late in Australia, and yeah, from where all the authors are. And I think in Michigan it is what, 8 or 9 o'clock? Is it Eastern? Or
almost 9, yeah.
Okay, yeah, so Eastern time. Yeah, okay, then thank you everyone for being here and giving your presentations, and have a wonderful day. I don't know, like, or night, whatever it is. Have a great day. Thank you.
Thank you.
Thank you. Bye.
Bye.
Thank you. Bye.
Bye.